How does bare metal become a virtualized infrastructure for VPS hosting? Imagine turning a powerful, dedicated server into many smaller servers that can run different websites or applications all at once. That's what happens when bare metal becomes a virtualized setup for virtual private server hosting. First, a physical server, called bare metal, is set up with hardware like CPUs, memory, storage drives, and network cards. These servers are built to handle lots of data and traffic. To prepare it for virtualization, the server's BIOS or UEFI settings must enable virtualization features like Intel Virtualization Technology or AMD Virtualization. This step is essential for smooth operation later on. Next, instead of installing a regular operating system like Windows or Linux, a special software called a bare metal hypervisor is installed directly on the hardware. This hypervisor acts as a thin layer that manages the hardware resources. Popular options include VMware ESXi, Microsoft Hyper, and kernel-based virtual machine. Because it runs directly on the hardware, it avoids the extra overhead that comes with running a full operating system first, making the virtual machines faster and more efficient. Once the hypervisor is in place, the next step is creating virtual machines. These are like mini computers that run their own operating systems and applications. The hypervisor divides the physical resources, such as CPU cores, RAM, and storage, among these virtual machines. For example, a server with 16 CPU cores and 64 gigabytes of RAM can be split into 4 virtual machines, each with 4 cores and 16 gigabytes of RAM. Each virtual machine acts as an independent VPS, giving users their own dedicated environment. Configuring network and storage is also key. The hypervisor allows setting up virtual network interfaces, so each VPS can have its own IP address and connect to the internet. Storage can be managed with technologies like RAID or logical volume management to ensure data is safe and flexible. Each VPS can have its own disk space, which can be expanded or adjusted as needed. After setting up the virtual environment, each VPS gets its own operating system. This can be installed via ISO images or network boot methods. Users can choose different OS versions depending on their needs. For example, one VPS might run a Linux server, while another runs Windows. Finally, the hypervisor provides tools to monitor and manage all the VPSs. Administrators can see how much CPU, memory, and bandwidth each VPS uses. They can also add more resources or move VPSs to different physical servers if needed. This flexibility makes managing many websites or applications easier and more cost-effective. In the world of internet services and web hosting, this process allows data centers to host many websites on fewer physical servers. It reduces costs, improves performance, and makes it easier to scale resources. Because the hypervisor communicates directly with the hardware, it cuts down latency and bandwidth issues, keeping websites fast and reliable. So, turning bare metal into a virtualized infrastructure for VPS hosting involves installing a hypervisor directly on the physical server. This hypervisor then creates multiple isolated virtual machines, each acting as a separate VPS with its own resources and network connection. It's a smart way to get the most out of powerful servers while giving users flexible, independent hosting environments.